And we should be live. I'm gonna check the stream.
It
The
says we're
streams.
live.
It says we're
We
live.
feel live.
We'll see people joining in a minute. And I'm just gonna make sure that we are streaming in all the right places. And
Streaming.
looks like we are. If people are already here, say hello in the chat. And it's always kind of fun to maybe hear where you're watching from. Sometimes it can take a minute, I think, for the full streams to launch. All right, yeah, confirmed. I see us up here live on YouTube and on LinkedIn. And again, people will be joining in, and feel free to say hello in the chat.
Cool. Hello, chat people. Thanks for having me on, Sage.
Yeah, thank you, Leo, for coming on. We'll get started here in a minute, but again, we'll wait a minute for people to join in, roll in. I see people rolling in right now. So again, if people want to say hello in the chat, I'll say hello in there so you see where it is. But it's really fun to kind of see where the audience is watching from, at least. But also, if you want to share a little bit about maybe what you're working on, that can be fun as well. And if you're doing something related to computer vision or robotics, that's always really cool to hear about.
Yeah, let us know.
All right, so I'll get started with a quick kind of intro to what this is. Welcome, everyone. My name is Sage Elliott. I'm going to be the host for today's Union Fireside Chat. At Union, we build tools around ML orchestration and making data and AI pipelines more robust. You might know us from our open source work on Flight and Pandera. You can check out everything we're doing at Union.ai. We just launched a serverless version of Union as well, so if you want to check that out, you can go sign up right away. But today's chat isn't about us. We have Leo Dirac from Groundlight with us. Welcome, Leo. How's it going?
It's going great. Thanks for having me, Sage.
Awesome. Yeah, thank you so much for coming on. We're going to hear about all the really cool stuff that you're working on. But the topic for today's fireside chat is the future of computer vision and robotics. And you're doing a lot of really cool stuff in that area right now. I think the headline, if I go to Groundlight.ai, which everyone should go to, and the link is in the description, I think the headline is the future of computer vision right now on the site. So very exciting time.
Absolutely.
All right, before we get going, could you provide an introduction and let us know a little bit about your background and a little bit about what you're currently working on? And I'm sure we're going to dive way deeper in that later as well.
Yeah, totally. So I cut my teeth in machine learning and AI at Amazon starting in 2013, where I was one of the first deep learners in the company, and joined to launch the very first AWS machine learning service called Amazon Machine Learning. Nobody remembers it or uses it. It was this simple linear regression service that we poured our hearts and souls into, but it was a little early and wasn't positioned exactly right. But I learned a ton about ML ops and what it takes to build real machine learning systems there at scale and production quality. And then I hopped over to the retail side of Amazon, figuring that with all this cool deep learning neural network stuff, it'd be easy to make $1 billion for the company, improving their recommender systems. And that was right. It actually took a few years to make $1 billion for the company. It's kind of ridiculous the scale that they operate at, but fraction of a percent improvement in recommender systems means a lot over there. And then went back over to AWS to build SageMaker, and I was one of the first engineers there and designed all of the AutoML and tuning stuff for them. Ended up leading the robotics and reinforcement learning parts of SageMaker, and after 6 years at Amazon, decided I was ready for something new. So set out, teamed up with an old college friend, and for the last few years, we've been building Groundlight, which is pretty exciting, and we'll get into.
Awesome. And how? Just to tack on another question to that, what got you interested in machine learning first?
Yeah, that's a good question. I was working at a social media company, and we had teams of undergrads who were being paid $10 an hour to label tweets and Facebook posts as good or bad, positive sentiment or negative sentiment. And I watched this company grow this is clearly a useful service. Lots of people wanted and needed this. And I was thinking to myself, wow, this is nuts that there isn't an algorithmic way to do this. And so I started doing some research, learning about what machine learning was. Sentiment analysis, natural language processing is like I think at this point, pretty well understood field, which does exactly that. And around then, Andrew Ng launched his very first MOOC on machine learning, learned the basics, and was like, wow, this is super, super cool, right? This is everything that I've spent my career learning about computer science and all my old background in physics and math coming together to do really amazing stuff. And so just really poured my heart and soul into it. And pretty shortly thereafter, neural networks had their big breakout moment when the ImageNet competition was first won by AlexNet. And I remember watching the results of this and all of the online discussion about how Krzyzewski beat the pants off every single computer version expert, like this young grad student who would just stand up and openly say, I don't know a thing about computer vision, but I trained this neural network and it got like 40% right, whereas y'all are like struggling to get 15 or 16% right. And then the reaction from the CV community was like, this is nothing. It doesn't mean anything. It's a fluke. Like, this is going away. Like, what are you talking about? Like, this is nuts. Of course, this is like the world is changing right in front of us. So I just dove in and like started buying GPUs and learning CUDA and whatever it took.
That's awesome. It's always, I feel like most of the people I talk to have everyone has a different background, but it's often like there's a problem that I'm having right now, and I'm sure there's a better way to do it. And then that's how everyone kind of discovers like machine learning, or that like that's what I did too. I discovered like computer vision because I had a hardware quality problem. And I was like, I'm sure I can use computer vision to look at this, but I didn't know anything at the time. And then I learned enough to build basically a visual QA system at the time, which was really cool.
Nice. Yeah.
Awesome. So our main topic today is the future of computer vision and robotics. Before we get into the future of those technologies, we can talk a little bit about what they are first. I'm guessing that most of the people listening right now probably know kind of what computer vision is a little bit. They've probably seen applications or maybe even built things themselves, but maybe you can give us a definition or maybe some examples that you like to share when describing it. Like, what is computer vision?
Yeah, totally. I mean, it's a great thing to talk about, right? Because AI is taking the world by storm, right? And a lot of people equate AI with generative AI, which is things like Stable Diffusion that can render images and movies, or ChatGPT that can author text and answer questions. And it's all generalizations of machine learning. And machine learning's had generative capabilities for a long time. It just sucked before transformers, to be perfectly honest. And computer vision is different people have different definitions, but I just think of it as the part of machine learning that deals with visual input. So it's any algorithm that takes an image or a video, or perhaps some hyperspectral camera data, something like that, and tries to understand it and make sense of it. And so this can be just like answering binary yes no questions about it, or putting it into one of n categories, or counting objects, or figuring out the depth to various objects in the scene, like masking out the background, for example. Slack or Zoom can make you blur your background, and that's a computer vision algorithm that finds out which part of the image is the person that we want to keep not blurry, and then which part is the background that we want to make blurry. So generally, computer vision is this set of algorithms for analyzing images and video and being able to make sense of them and do useful things based on them.
And I think you made a really good point that most people now are thinking of like generative side, or even probably all the really complex like deep neural network side. But there's a lot of old, older or more traditional computer vision algorithms that like you don't always need deep learning for the issue.
Yeah, exactly. Like, I mean, scanning a barcode is computer vision, or a QR code or something like that, right? These are super well trodden, incredibly reliable techniques at this point. But they used to be pretty hard. But now they're pretty easy. And so we're in this phase where a bunch of computer vision stuff that you might expect to work reliably today with like the amazing things that are going on with transformers, that like the best CV algorithms are still pretty bad at some pretty simple tasks.
Awesome. And again, I'm guessing that a lot of people listening have an idea of, robots in their head and robotics, but it's definitely feels like I mean, there's been just amazing developments in the last several years. So I guess maybe we could also describe like what is robotics, or do you have an example you like to talk about, just like we did with computer vision?
Yeah, totally. So there's this funny thing that happens with robotics, right? We all know the sci-fi version, which is a walking around mechanoid humanoid that's not biological, but entirely machine-based, but acts otherwise just like a person, right? And we are still nowhere near that, except in the last few years, we've started to see some robots that take that shape. So it's like, but generally, well, like, what's a real-world robot? The most common robot in the real world is Roomba. And the funny thing is, it's a robot vacuum cleaner. And funny thing about robotics is that people associate the word with stuff that doesn't work super well, because Roomba, people don't call it robots very much. They just called it a vacuum cleaner. But when it first came out and it didn't work too well and made a bunch of mistakes, then it was a robot. But we kind of have this sense in society that robots are kind of dumb and awkward in the real world, and that's true because aside from Roomba, basically all robots are in factories. There are these arms that weld things together. More and more, we're seeing pick and place systems in the warehouses and fulfillment centers of your e-commerce sites that will take an object out of one location and put it into the other. And that task, which sounds really simple, is actually still very difficult and needs to have really careful constraints put around it. And so one of the key like kind of observations about robotics in the real world today is that they're just not smart enough to deal with any kind of chaotic or natural environment. So if you want to use robots in a commercial sense, in an economic sense, you build an entire facility around the robot. So like Ocado in the UK, they have these massive buildings which are robot warehouse grocery stores. And it's not wrong to say the entire friggin' building is a giant robot, right? And it's just got these things running around, picking up food and bread and things like that, and putting it into bags for people. But you kind of like, you can either have a smart robot or a dumb world. We don't have smart robots yet. So what we do is we dumb down the world that the robots operate in to make them useful and effective. And it's kind of this observation that really led Avi and I to start working on Groundlight.
Yeah, it almost seems like now, like people have probably seen like there's Spot Robotics, or Spot the robotic dog that a
Boston
lot of people are
Dynamics, yeah.
familiar with. Yeah, Boston
Got one
Dynamics.
right
There's
out there. It's lying
nice.
on the
Yeah.
ground next to Tim.
You're making that
Spot's
smarter,
amazing,
right?
right? Yeah, it's like Spot's amazing. Or like you can see videos on YouTube of these humanoid robots doing parkour, and like occasionally they nail the landing, right? And it's phenomenal. But we've seen like Spot can like walk into the kitchen, open the door, pull open the fridge, pull out a can of soda, and walk out and hand it to me. Like, it's mechanically capable of all of that, but it needs supervision. It needs a person really telling it basically exactly what to do, because it's not smart enough to understand this chaotic world, which is our office. Like, our office is, yeah, all right, it's pretty chaotic, but like, it doesn't matter. Like, the level of constraint that you would need in an office environment to make a robot effective, like, nobody would want to work there, right? Your desk couldn't move more than a millimeter, or things would go wrong, right? That's how environments where robots are meant to operate have to be laid out.
Right. So it almost seems like the hardware is there. We've seen all these really cool videos, but it's almost to me it seems like a software problem now, right?
I agree with that, and there's subtleties to it. Like, there's a lot of really interesting layers. Like, like perception and control are like parts of software that have more or less to do with the hardware. Like perception depends on your sensors, like LiDAR and 3D sensing are still pretty common on the perception side of things, and control is like really intimately married to the motors in the system. And as AI grows into these things, then those lines do blur, but I'd like generally I agree with you. Like we can see that the hardware is physically capable of doing the things that we need, and then it's the software, whether it's control, planning, perception, these different parts of the software stack that are missing, uh, um, keeping robots out of our everyday lives and being more helpful.
Awesome. And we might have touched on this a little bit, but now that we've talked about like robotics and computer vision, and we've been talking about the software side of it, do you have any like favorite use cases right now? Maybe even something that you can share potentially from Groundlight, where you're seeing robotics and computer vision like work well together today?
Yeah, totally. So mobile inspection is a really interesting one, right? So this is, I think, a pretty good marriage of the current state of the art with robotics and kind of the limitations of perception. So if you work real hard, like companies like Boston Dynamics have done, you can get a robot to reliably walk around an environment and like go up and down stairs and go through doors, like the stuff that's frankly kind of mind blowing compared to what was possible just like 5 years ago. Um, but then it can look at things, it can point a camera at things. It's got this really nice high resolution camera on the end of its arm, and it can go like, what is that? But it still has no idea, even simple things like, is the gauge in the red or not? Like, is the pressure too high on the oil rig? Is like, that's a classic use case. Or another example of yeah, and so we've integrated with our system into the Boston Dynamics Spot package, and so you can drive a robot around and use Groundlight to get like high quality answers to these questions. But another example of mobile inspection that's really useful is drones flying around and inspecting power lines, or again, big facilities. Like oil refineries or solar arrays, where it's just hard to have a person walking around. And generally, people walking around with clipboards, they are ripe for automation, because now robots are pretty good at walking around. Like interacting with the world is still relatively hard, but they're getting relatively reliable at that. And uh, and so being able to automate the judgment side of things of what they're looking at and what needs to be done based on what's going on in this environment, that's kind of ripe for the picking. So like this turns into various forms of um, quality control and things like that.
Yeah, it seems like yeah, all the quality control inspection side, like you're saying, that's even how I got into computer vision. But now
Hmm.
like with technologies like Groundlight, it's so much more robust and capable of so many different things without like kind of out of the box. I'm sure you can use training and stuff to add more accuracy to it, but there's so much more you can do reliably in a, like you said, kind of a chaotic world, not a world built for robots now.
Totally. There's, I think, a good question on YouTube I'd love to answer about deep learning and RL reinforcement learning, and how this interacts with control systems and perception. Because this is literally what I spent my last couple of years at AWS working on, was the RL system, the reinforcement learning for system for SageMaker, and it's kind of surprising the actual state of the world right now. That most robotic systems, so reinforcement learning is this ability to have your system predict not just a single result, but a path, a plan, a series of results. And so you can train a robot to, using reinforcement learning, to do things like stand up or run, uh, or what have you. And there's some really inspirational videos of like robots acting like babies and learning to crawl or stuff like that from nothing, because with RL, all you need is a reward signal, kind of some hint that you're doing better than you used to. And so it's possible to drive motor torques from RL and have much more complex plans and ability to deal with weird environments versus what's possible with traditional control, just like PID loops and things like that. And you look at something like, parkour, jumping around robots or what have you, and you might assume that it's all based in RL, but it's not. Like RL is like so many things in modern AI, it's unreliable and it's hard to train. And so the vast majority of robotic systems, the control layer is still traditional, carefully tuned 20th century algorithms for control. And it's a lot of hard work, but many engineering years go into this, and you can make it reliable. And now some systems are starting to try the reliable traditional control technique for a while, and then automatically switch over to RL based training if it's failing. And we're starting to see that happen. But RL certainly will probably play an increasing role in these low-level control systems, like how the legs will operate and things like that. But it's not nearly as prevalent as you might think just by kind of taking an outside look at the state of algorithms and what have you.
That's a really good point that we didn't explicitly bring up when we were talking about like Boston Dynamics doing the flips and stuff with Atlas Robot. Just like you said, you might think that's AI, but it's not.
Yeah. It's just like, I don't know how many engineers working for a real long time to try to get that thing to stick the landing.
That's wild.
Right.
And I think there's a couple other questions that we can hopefully get to a little bit later. But I guess this is kind of really the main question from the title of today's stream is, what is the future of computer vision and robotics? So in many ways, like all the stuff we've been talking about, like it feels like we're already in the future. Like if you were to think of or when I was building stuff with computer vision 5 years ago, it feels very different now. It feels like we're kind of there. But with all the recent developments, where do you see these technologies developing or being adopted in the next several years?
Yeah, absolutely. So, I mean, the trends are fascinating, right? Like, everybody who works in this stuff professionally agrees that robots are going to be coexisting with us in our workplaces and our homes and on the streets and sidewalks of our world at some point. There's no question in really anybody's mind if it's an if. The question is when, and who and how are going to make it happen. And robots, kind of like fusion power, have been decades away for a very long time, and now that's maybe getting shorter because we're seeing some of these barriers taken down, right? So the mechanical problems are to an extent solved. Although I'll point out there's a really important one, which is dexterous manipulation, the ability to operate a robotic hand and even just like pick objects up is still really, really bad. Like there's a couple robots out there in the world that use like hands with multiple fingers, and they are rare. It's just like suction cups are the state of the art. Like that's the way most real world things get done. But there is no question that these problems will be solved. And we kind of, with AI and deep learning, we see a path to solving these software problems. But at the same time, we also are seeing kind of the boundaries on and limitations on this stuff, right? So now we have LLMs that will confidently assert an answer to any question you ask them. And this is great if you want to write a poem, or maybe if you're trying to compose an email to somebody. Maybe it screws up, maybe it gets completely wrong, right? But if the email goes out with completely the wrong words in it, nobody gets hurt, right? If the wrong products get recommended on on a shopping site, I mean, people could get pissed off. They could get really embarrassed. but it's nothing like what happens if a robot walking down the street makes the wrong decision and just swings its arm and knocks somebody out. Right? The moving AI to the physical world is a real challenge ahead of us. And my opinion is the only way that this is going to happen is with heavy human oversight. And so that's that's really the basis of what we're doing at Groundlight is integrating human monitoring and oversight and judgment with automatic AI algorithms. And so it's really not clear if or when. I mean, I guess when we're really going to be able to judge to trust these AI models on their judgment. To be able to operate completely autonomously without oversight. You know, there's plenty of like horror stories and sci-fi written about this going badly, but fundamentally, I think the future needs to be this kind of cyborg control where machines are making a lot of the decisions, but the judgment on high-level tasks is still left up to people. So it's kind of like broad arc of how I see this stuff playing out. And like we're seeing chunks of it today, right? There is some college campuses with delivery robots driving around largely autonomously that will, bring you a pizza in the middle of the night by driving around campus and going up the elevator. These things have a lot of human control going on in the background, by the way. Autonomous vehicles like self-driving cars, they're robots, right? They're big, powerful, dangerous robots, which the control is incredibly simple, right? You have a steering wheel and you have a gas pedal and a brake pedal. It's got like maybe 3 floating point numbers to describe its entire operation. But it is in a sense, it's the highest stakes game there is, because in that scenario, you've got some cameras and you've got 30 milliseconds, maybe 50 milliseconds to make a life or death decision every single time. And so that's why, in self-driving cars, again, you've got this kind of cyborg hybrid of the machine trying to do its best, but it says, don't take your hands off the wheel because I'm trying, but who knows when I'm going to screw up. Right. So I think that's really the path for a while, is that the hardware is going to keep getting better. And they're going to be able to make more and more decisions autonomously, but it's going to be a real long time before we fully trust them. And I'm not sure that we should. Right? There's this level of RLHF kind of training of getting them to behave properly around the outsides. That's just kind of critical, especially when you're talking about real world consequences of machines breaking things or hurting people or causing real damage.
Absolutely. I think bringing the unreliability of a lot of the machine learning type of stuff into the physical world, just like you said, requires oversight. Because, I mean, again, look at using is maybe a bad example, but look at LLMs and all the hallucinations. If you're having something like that with as its brain trying to do something, and it's gonna do something that hurts someone or completely different than it should be doing, it definitely needs oversight if it's going to affect like the real world with humans in it.
Yep.
So this is a perfect transition. So tell us more about what you're building at Groundlight and how it helps solve this problem.
Yeah, so we have a computer vision platform that integrates human oversight and classic CV algorithms. I guess it's funny to use the term classic now, because when I say classic here, I mean CNNs, convolutional neural networks, all the great deep learning techniques like YOLO and RCNN and things like that, which are the bread and butter of real world non-trivial CV. Groundlight gives you all of those algorithms, but powered with human judgment on the backside. So we take natural language descriptions of whatever task you want. Simple discriminative tasks like binary questions or object detection, And we build a model for you based on that question and humans who back up the algorithms. So we carefully calibrate all of our models, and we know when to trust them. And this is really one of those difficult writ large questions in the world of AI, is like, how do you know when to trust it? And there are signals coming out of all of these systems that you can pay attention to. The standard answer is like, well, just chase nines. We just need it to be 99.99 whatever percent accurate, and then we don't worry about it making mistakes because it just won't make mistakes. But that's really rarely the case. And these systems, even if you get them really good, even if you chase down a bunch of nines, if the world changes and the things that you're looking at are unlike your training data, then most CV systems will just confidently predict an answer based on whatever is closest to the things it was trained on. And Groundlight system will detect when the domain is shift, when things look different from what it's used to. And in a robotics system, it will pause and it will ask a person, what should I do? So we've got integrations with a number of robotic systems. I showed you the Spot Dog. We have a partnership with Universal Robots, who make the cobot arms. And so you can program a cobot if it's like tending a milling machine or something. It's like, this is a pretty common task. You got this $500,000 piece of equipment that very carefully scrapes pieces of metal, starts with a blank, and carves out exactly whatever shape you want according to your CAD design. But to do that, something has to load a blank, a solid block, a rectangle of metal into the machine, press go, wait for it to finish, and then pull it out. And so usually this is a tech, this is a person whose job is to sit there and monitor the machine and load it up, make sure nothing goes wrong. When it's done, pull it out. It's really common to set up these machine tending applications where you have a robot arm that grabs the blank, puts it in the vise, clamps the vise down, doesn't actually literally press the go button because you can do that electronically, but waits for it to finish and then pulls it off and puts it in the done stack and repeats. And typically these things, the ROI is amazing. Like you can pay for the robot in 6 months sometimes versus the salary of a person to keep an eye on it. But it's also really dangerous because if something goes wrong, these systems are generally blind, and they'll just keep putting parts in when the mill bit broke off, and then you risk damaging your $500,000 mill because nobody noticed that the drill bit was broken. So this is a common application for us with the UR plugin to have cameras watching a machine tending cell and making sure that things are working properly while it's going on. But yeah, so to circle back, we give people the best of traditional computer vision algorithms with live human oversight and the ability to have a system that works from day one just based on instructions. And sometimes it's slow, especially to start with, because it needs to ask a person what the right answer is. But those human judgments get instantly trained into the model. Like a few seconds later, we got the new model trained and deployed, and you push it down to the edge and get your answer in milliseconds from a local GPU as well. So it's kind of this cyborg vision combination of human oversight and labeling, interpreting instructions with classic, reliable computer vision algorithms.
Yeah, it's awesome. I've used it a little bit, trying it out, and I was
Cool.
wondering, where can other people go to try using it out? And I think you can sign up and use it right away right now, right?
Yeah, absolutely. It's available. We have a free tier that's it's good enough for hobby projects for sure. Just go to Groundlight.ai and click try it free. You can create an account and start using it. Download the Python SDK. We've got some tutorials showing how you can write a working computer vision application in tens of lines of Python. It becomes incredibly simple. Instead of having to gather a data set and train a model and deploy a model, you just need to think carefully about the instructions for what is a yes and what is a no. And you won't think of everything. There will be edge cases all the time, of course. There will be something which isn't clear, and then the cloud labeling staff will flag that, and they'll say, you didn't tell me if you were asking me if the door is open and it's ajar, it's not latched, but it's closed. What am I supposed to do in this case? And then that's up to you. Like, what are you trying to accomplish here? Or hey, the lights are out and it's completely black. I can't see anything. What am I supposed to do in this case? Like, these happen all the time. Like, basically every detector people set up, no, they don't think about these edge cases. And this is what I think is the modern way to do computer vision. The problem is not so much gathering the data, training the model, doing all this algorithmic stuff. It's knowing really what you're trying to accomplish and the intent, and codifying that in a way that a system can interpret. And yeah, we have humans that do that. VLMs continue to suck, the visual version of LLMs. They're getting better. We've got a much better one in the works that's going to come out hopefully pretty soon now. But it's the key is describing exactly what it is that you want out of the system, more than kind of the mechanics of making it happen.
Which sounds easy, but could be pretty hard to do sometimes. Like you said, there's going to be edge cases that you don't think about.
There's always edge cases, right? There's always edge cases, and it's yeah. And that's really, I think that's a key thing. And like like the LLM folks are dealing with this as well, right? Sometimes it'll just hallucinate an answer. Sometimes they're smart enough to say, I'm not sure, I don't know what the answer is in that case. And this is tricky if you're writing a piece of code, right? You want your robot to walk up and pick up the trash can, but the trash can isn't there. Like, okay, you gotta like these when you're automating something, thinking about how to deal with all of these edge cases, it's tricky. And these are the things that we're all going to work through as we move into the next generation.
Awesome. Yeah, that platform makes it really easy to like send images and kind of label those questions that you're asking about it, if people want to visualize kind of what that platform looks like a little bit.
Yeah, and it's like, practically speaking, setting up these projects is you end up spending a lot more time futzing with the camera and getting OpenCV installed properly, or getting your RTSP feed working right. Since we've invested in some open source projects that really try to simplify a bunch of this stuff, where you can just describe in a universal YAML file where the images come from and how you want to like crop and things like that, and kind of separate out that aspect, which is all too common and frustrating, from the like coding the logic in of what you want. FrameGrab is the name of the library that we support for that, and it's invaluable in this kind of thing. I was just last night setting up a system to help ensure the domestic tranquility of my household, and encourage people to wash their dishes, which I think is a nearly universal problem in this society. But yeah, I spent 2 hours futzing with the camera and the Raspberry Pi, and about half an hour writing the code.
Awesome. And you yeah, it's easy to fairly easy to consume images from edge devices like a Raspberry Pi, like you said.
Yeah, absolutely.
I know you also recently launched a hardware product, I think, called Groundlight Hub.
Yeah, that's right. So the Groundlight Hub is aimed at commercial customers and folks who are not developers, and they want a solution to whatever it is. Like, maybe they already have an existing set of security cameras in place, and they want to know, like, in a restaurant, is the the dumpster behind the building overflowing because we get charged extra money from waste management when that happens. And like, this seems like maybe it should be a pretty solved computer vision problem. And like, I don't know of any um, existing model that will do this for you. Certainly, the VLMs get easily confused by this, but we'll train a custom model for you. And so with a hub, you just buy it, you plug it into your existing camera systems, and set up whatever question it is you want monitored, and then configure it to send you a text message whenever there's a problem. Or people are using this in for quality control, like in order fulfillment. Like, people make mistakes all the time. Like, they'll put the wrong thing into a box, and so having the Groundlight hub can take a picture of something before it goes into the hub, and check against the fulfillment system. Like, does this picture of the item in the box match the thing from the catalog? And that's a pretty tricky computer vision problem, this kind of comparison, because it's a deliberate and very large domain shift from the beautiful catalog image to the badly lit production floor where this thing's folded into a box. And doing that comparison, yeah, it's actually kind of tricky, but that's one of the things that people are using the hub for.
The hub can take away some of that pain of fiddling around the OpenCV on a Raspberry Pi.
Yeah, absolutely, right. You just yeah, I mean, the hardest part is remembering the password to your existing cameras. And like, sometimes maybe you just buy a new camera because that's easier than looking up the password for the old one.
Awesome. And I wanted to kind of combine maybe a couple of questions from the chat if you still have time to answer at least one more. A couple of people asked about synthetic data for, I guess, training robots. And I know that's, I think, widely used in the autonomous industry, or it was before they had cars. Now there's a lot of cars on the road, so they probably have way more real world data, but you still might use synthetic data to create use cases that you don't have yet. Like, obviously, you hope your cars don't crash or are around, specific complex construction sites or something like that. What do you think about, I guess, using synthetic data for training, robotic systems?
Yeah, 100%. I mean, it's like we do that behind the scenes for you in a number of cases, and it's key. Like, there's a bunch of ways to do it, and it's like there's kind of a continuum from using stable diffusion to hallucinate a completely novel scene and using that as training data, all the way down to these algorithmic tweaks like SMOTE, where you just jigger the vectors, and it's kind of like synthetic data that you've never seen, and kind of everything in between. It's a critical part of the world in robotic systems. The challenge that people run into training robots to behave in simulation is called the sim to real challenge. So one of the things that I worked on when I was at AWS is Deep Racer, this thing where you'd train a race car to drive around the track in simulation, and then put it on the actual physical track in Las Vegas at the show, and see if it could do it. You can definitely train a system to act arbitrarily well, like get your quality number, whatever you want it to be, in simulation. But then there's this question: are you overfitting to simulation? You've created this new problem, which is now getting your simulation to be as similar to the real world as possible. And so roboticists have a term for this. They call it system identification. And now you have and that's particularly around the control problem, right? So if you're using RL to train the control part of a robot, well, your model needs to know the exact mass and length of every joint, and it needs to know the exact amount of friction between every joint. And boy, that's real hard to estimate. And so you've got this list of dozens of numbers that go into your simulation. And those need to be correct, or else the thing you train isn't going to work in the real world. And yeah, so trying to estimate what those are is a field of, it's a specialty and academic study in its own right. There's techniques for dealing with it, like automatic domain randomization. I think is a pretty cool one. But it's I say like synthetic data writ large is simultaneous. It's critical, but and super useful, but by no means does it just solve your problems, right? It's another tool in the toolkit that helps, and it can help a lot in certain circumstances, for sure. But it brings its own set of complexities in when you start to use it.
You should look at using it if it helps your problem, but be prepared to have a new set of problems potentially with it, right?
Absolutely right. I mean, I think the key takeaway message is your simulation is never the same as the real world. And if you train your model, if you train your robot, your CV system to work with your simulation, then that maybe helps, but only insofar as the simulation is similar to reality.
Awesome. And this has been such a fantastic conversation. And thank you so much for coming on. Before we wrap up the live stream, is there anything else you want to shout out? I've shared the link in the chat and the description for Groundlight.ai, and I know people can sign up there. I think I also shared the link to the more recent tutorial that has come out. That's a good introduction to it. Anything else upcoming that you want to give a shout out to for?
I mean, if you're in Seattle, we're having a meetup next week. The Seattle Computer Vision Nerds. That's pretty exciting. Stay tuned. We got some pretty cool stuff coming down the pike with our SDK. I'm not going to pre-announce it yet, but pay attention. We got some new features coming that I think are going to be pretty exciting to a lot of people. And yeah, sign up for an account. If you go to Groundlight.ai, if you have any questions during business hours, there's usually somebody paying attention to the chat. Just feel free to hit us up and ask us a question if something's confusing about how the models are working or something in the docs of the SDK or something. Where somebody's happy to help.
Awesome. And I shared the link to the meetup as well, so people can go join that. And I'm probably going to be there myself too. I'm excited to hang out in person in Seattle. I'm also in Seattle, in case people didn't know. And awesome. Well, thank you so much for taking the time to answer all these questions. And thank you again for everyone who joined as well and asked really good questions in the chat. I know we didn't get to every single one of them, but I think we're going to wrap up our stream now. So I just want to say thank you for joining in. And again, you can also go connect with Leo. I think I have links to your LinkedIn and Twitter as well, and people can
please do hit me up if you have questions.
Awesome. Thank you again. I'm going to hit end now on the stream. Sometimes it takes a minute, everybody. So there can be an awkward pause. But yeah, thank you, Leo. Thank you, everyone, for coming on.